Next up, we have combination. Now, as the chapter says, it's combination and permutation. So they are quite related to one another. So combination is just like permutation. The only difference is that the ordering in the selection is not important. All right. So if AB is the same as BA, ABC is the same as CBA, right? The ordering, the internal arrangement of the items does not matter. Then we use NCR, we use permutation. So the idea is the same. If you have n different items in a pool, right, on the left hand side, in the pool you have n different items. Every time you pick out of them and put it in the bag, right? Now this time we do not line them up. We do not arrange them, right? You can note different keywords to distinguish between NCR and NPR, permutation and combination situations. If you have keywords like line up, arrange, right? These are keywords that prompt you to use NPR, permutation. On the other hand, if you have keywords like the number of groups, alright, the number of combinations, then this will give away that we use NCR combination to do that. When you use NCR, the ordering within the group is not important, right? So you just put them in the bag and shake it. So it's just the same. The ordering is not important. So there are now NCR ways to do that. For example, we investigate what is 4C3, right? What is the meaning of 4C3? 4C3 means that if you have 4 alphabets, say A, B, C, D, originally, alright, and every time you take 3 of them, say I take the 3 alphabets like A, B, and C, alright, A, B, C. Oh, but I can line them up in B, A, C, like B, C, A. It might as well be A, C, B. How about we can also have C, A, B, and C, B, A. Is that all? Alright. However, in the NPR situation, we have to consider all these different permutations, different arrangements. However, in the NCR situation, they are the same as just one group. You put the 3 alphabets A, B, and C into the bag, into a basket, alright? And you just shake it up. You just, randomize the arrangement of this, alright? So that's one bag. A, B, C is one bag. So how many such bags we can collect? We can collect A, B, C is one bag. We can collect A, C, D, that is another bag. Alright, never mind the internal arrangement, never mind the internal order. It can be A, C, D, it can be D, C, A, it doesn't matter. Alright, because we are talking about combination. What else? We can have like A, B, D, alright? A, B, D is another possible bag. Alright, and also we can have B, C, D, right? Is that all? Is that all? These are the 4 bags we can collect. So there are now 1, 2, 3, 4 different bags. Alright, 4 different groupings. So we have 4C3 equals to 4. Alright, that is the meaning of NCR. Alright, 4C3 equals to 4 because there are 4 such combination, 4 such groups you can make out of the 4 letters A, B, C, and D. Right. So now that is the meaning of the NCR. So how do we calculate NCR? To calculate NCR, we follow once again the NPR notation. We can use factorial to do that. Alright, NCR will be n factorial divided by r factorial n minus r factorial. Alright. For comparison, if it is NPR, that is n factorial divided by n minus r factorial. Very similar. Alright. The only difference is the r factorial. If you include the r factorial in the denominator, it is NCR. If you drop it, then it is NPR. So in other words, you can have NCR is the corresponding NPR divided by r factorial. Alright. Now that is from the notation of the factorial. Also, if you remember last time, right, we also shared with you another way to do the NPR, and that is a series multiplication. You multiply, adjacent numbers together. We can do things similar like that, alright? For NCR, it goes like this, right? For 4C3, for example, we can have 4C3 equals to starting from 4, alright, we multiply downwards by 3 numbers, so 4, 3, 2, alright. But then at the same time, we have a step up multiplication, 1 times 2 times 3. We can do that. That will have NCR, alright. 4C3 will be starting from 4, alright. We multiply by 3 numbers, starting from 4, alright. We do a downward multiplication for 3 numbers, and so that is 3 numbers, alright. And then at the denominator, we do a step up multiplication starting at 1. Alright, so that's how we do NCR. In other words, we can do it like this. We can have n times n minus 1 and so on, all the way down to n minus r plus 1. Altogether, there are r numbers there. There are r numbers here. Alright, and then at the same time, at the denominator, we divide it by 1 times 2 times 3 all the way to r. There are another r numbers at the denominator, right? This is the second way we can do the NCR. The second way we can do the NCR. Of course, the third way is to use the calculator, right? Go pick up your calculator and find out the NCR button in the calculator. Alright? So now I hope you find the NCR button. It's next to the NPR button in the calculator, right? So remember, there are 3 ways we can do the NCR calculation: using the factorial formula, using step down multiplication like this, or to use the calculator, right? Let me show you one more example on how to do the NCR calculation. For example, if I want to do how about this? Alright, there is a lottery in Hong Kong. We call it Mark 6. Alright, let's take a look at the Mark 6 policy. Alright, so here is the not Mark 6 lottery, right? Mark 6 is to draw 6 numbers out of 49. And the ordering is not important, right? It doesn't matter which number comes up first, which number comes up next, alright? As long as you got the 6 numbers, you win the lottery, the first prize, right? So the question is, how likely is that you can win the lottery, the first prize? Or in other words, how many ways the Mark 6 lottery can come up? How many ways are there for the results of the Mark 6 lottery? If you want to buy all of them, right? If you want to bet in every possible, if you want to buy a ticket that will guarantee to win the Mark 6, how much money you have to spend on that? Alright, so now the key numbers being this, there are 49 original numbers. Every time you pick 6 of them, alright, and the ordering is not important. So we know that the number of possible Mark 6 results will be 49C6. Right? There are 49 numbers. Every time you pick 6 of them, and the ordering is not important. Alright. If you want to calculate 49C6, you can use the calculator. Or you can also do it in this way. It's 49, and then you do a downward multiplication for 6 numbers. Alright. 9, 8, 7, 6, 5, 4. Alright. And then at the bottom, you do a step up multiplication, once again for 6 numbers. Alright, so 49 starts at here. Alright, NCR, this is N. And the R is here, is 6. Alright. So this is how we calculate, or you can use the calculator, right? And my calculator show me the result is like this. Now it's a huge number. It's 13,983,816. Alright. So there are about roughly 14 million ways. 14 million ways for the Mark 6 result. Alright. And every bet in the Mark 6 is $10. Alright. So the total bet will be $10 multiplied to 49C6. Alright. And that would be 140 million roughly. That is 1億4千萬. 1億4千萬. Alright. If you want to buy a Mark 6 ticket that is guaranteed to win, that will cost you 140 million. 1億4千萬. So what is the highest Mark 6 result? What is the highest Mark 6 first prize? Here is the highest Mark 6 lottery result, alright? It's 115 million. If you want to get that jackpot, if you want to do that 100% sure, you have to spend 140 million to do that. So, betting is never a good option to win money, right? Because, if you want to guarantee a win, you have to lose some money first, all right? So that's how we use the Mark 6 lottery result to indicate the application of the NCR. Also, there's another example. All right, here's a lunch menu, right? Let's see how many options do we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You have 15 dishes to choose from, all right? Suppose I want to have a dish that is, I want to have a lunchbox that has 2 dishes, all right? 2 dishes. So now the first question, is it NPR or NCR? The first question, is it NPR or NCR? Is it permutation or combination? In other words, in order to answer this question, the thinking is ordering important? Is ordering important? 雞翼搭燒肉, is it the same as 燒肉搭雞翼? If they are different, then we use NPR. If 雞翼搭燒肉 is the same as 燒肉搭雞翼, then we use NCR, right? So obviously, in this example, what do you think? Are they the same? If I order叉燒切雞, and then the shopkeeper says, oh, we only have 切雞叉燒, no 叉燒切雞, it's the same, right? So we use NCR instead, all right? NCR for this example. And secondly, do we allow repeat? Do we allow repeat? All right? If we allow repeat, then we cannot use the NPR or NCR. We have to go back to use another method to do that, right? I think we talk about that. Yeah, like this, right? If you allow repeat, we use a different approach, all right? If we do not allow repeat, then we use NCR. So once again here, do you allow repeat? Can you have 排骨搭排骨, right? And then you claim it's 2 dishes. No, I don't think so. You just waste money, right? If you want 排骨搭排骨, you just order 排骨, that will be fine, all right? So you do not allow repeat. So we use NCR. The number of ways you can have this 2-dish lunchbox, 2-dish lunchbox will be 15C2. All right, if you want to have a 2-dish lunchbox, the ways to do that is if you want to try every combination, right? You're so enough with this restaurant. You want to try out every combination. So you have to have 15C2, so many different ways, right? There are altogether 15 dishes. Every time you try out 2 of them. So what is 15C2? Of course, you can use the calculator, but it is also 15 times 14 divided by 1 times 2. 15 times 7 is 105. All right, it will spend you about 3 months. All right, to try out every combination. But of course, things will be much more complicated if you consider the sauce and you have different drinks to go with the lunchbox. But that will be another question another day.